And I would say what the word problem says. Kurt leans a 20-foot ladder against the side of his house. The ladder reaches to a height of 18.9 feet up the side of the house. What's the angle of elevation of the ladder to the nearest tenth of degree? Then I'm going to animate the word problem, whether that be icons or pictures that you have to bring in because you don't have faith in your drawing skills, or you're cool with a not so great drawing, because I am, as long as it's neat and I can see what you're trying to do. Here I've got a house. Here I've got a ladder that's leaned up against the house. Okay? And the piece of information that this says is that the ladder reaches to a height of 18.9 feet up the side of the house. So where is that 18.9 feet going?
Up the side of the house.
Up the side of the house. This would be 18.9 feet. What's the angle of and then the ladder is 20 feet long. So where's 20 feet going? Along the side of the ladder. 20 feet there, right? The question says, what's the angle of elevation of the ladder to the nearest tenth of a degree? So I need to close this in because the whole point here is to make a right triangle. And this question is actually asking for the degree. So this is not asking for a side length. It's asking for the angle, which would be in this little corner here. How do I solve for an angle? What's different between solving for an angle and a side?
-1.
You have to use the -1 buttons. So if x is in this corner and 18.9 is here, what relationship does 18.9 have to x? Opposite. And if my ladder length 20 is there, where is that located on my triangle? Hypotenuse. Which trig function am I using? Sine, right? SOHCAHTOA tells me that I use sine for opposite and hypotenuse. So the sine of the angle x equals the opposite side over the hypotenuse. So the sine of x equals 18.9 over 20. And then in my calculator, I'm going to write sine -1 of 18.9 divided by 20. And that will give me my answer. So this is a different kind of example because it's asking for the angle. You can do something like this as long as you involve sine, cosine, or tangent. You can use any of those. So 18.9 divided by 20 is 70.9. Okay. So on your word problem, you're obviously not going to have choices. No, you don't need to create the choices for yourself. You just need the word problem. You need the diagram, you need the setup of the equation, you need the work, you need the answer. And flagpole in Terry's schoolyard is 47 or 42 feet tall. So I've got a flagpole. Like out loud? Sure.
On a sunny day, the flagpole casts a shadow 20 feet long. What is the angle of elevation of the sun at that moment? Round to the nearest end.
All right, so I've got a flagpole that is how tall?
20 feet.
Nope. 42 feet. Then it has a shadow that is 20 feet. Angle of elevation from the sun. So where would the angle of elevation be? Right here. Okay. So how do I set up my trig equation? Ethan, head up.
It's opposite and adjacent.
Good. So this is opposite. This is adjacent, which means?
Sine.
Oh, so close. Tangent of x equals opposite over adjacent. So tangent of x equals 42 feet over 20 feet. And then because I'm looking for an angle in my calculator, I'm going to do tangent -1 of 42 divided by 20.
That's 2 point. It's 2 point something. That's 20 goes.
Right, that's the 40 and 22. But then the tangent of that is 64.5 degrees. Shh. Shush. Yeah. If you're looking for the angle. So if it had asked me, so Juliana just asked a great question. How do I know when I'm doing tangent -1? If I had instead of given you the angle to look for, let's say it had said, here's the height of it, here's the angle, let's just say it's 64 degrees. What's the length of the shadow? Now I'm looking for this side. So that scenario is still tangent, but I know the angle. So I'd say tangent of the angle equals the opposite side over the adjacent side. And then when the numbers in the bottom, when the variable's in the bottom, we take 42 and we divide it by the tangent of 64. And you should get something close to that 20. It won't be exact because we rounded, but it should be close to 20 feet. Does that make sense? So if my word problem has me looking for a side of the triangle, I'm using the regular buttons. If my word problem has me looking for an angle, I'm using the negative ones. Miguel. You have choices as to what you want your video to be done on. EduCreations is one of those options, just the way we just did it. The other option is to literally draw it out in Notability and then work it out while screen recording. There's just no pause there. So I would make sure I practice that over and over again. You can't pause screen record. You can't pause screen record, okay? You could also use, if you have, Explain Everything or Doceri. All that's fine. The benefit of Doceri is you can actually write the whole problem out. If anybody ever used Doceri, you can write the whole problem out without any audio. You can rewind it all the way to the beginning, play it back, and record your audio while you're playing it back. So you're kind of describing what's happening and it's already happened. That's fine too. I don't care how it is you make it, but the end goal is a video. A video with your word problem, with a drawing of your word problem, with the initial setup of your equation, and the solving of your equation. Do you understand what I expect from you? Yes? Okay, so let me show you, if you're using EduCreations, how you're going to save this.